jet velocity is 60 meter per second and the wind moves with velocity 14 meter per second in the same direction as the jet. The jet is deflected through an angle of 150 degree. The relative velocity reduces by 10% as water flows across the wind. Calculate the power developed and the efficiency. So here we have this curved wind. This wind, because of the jet which is striking on this particular wind, because of the shape of that particular wind, the jet deflects through an angle of 150 degree. So the theta angle, or we can say exit angle phi in this case will be 180 minus 150 degree. So it will be result into what? Basically 180 minus 150, 30 degree. Now this jet is striking with velocity 60 meter per second. So V is equal to 60 meter per second. Now the jet strikes a kind of curved wind which is moving with velocity U is equal to 14 meter per second. So here we have two important velocities. Now this wind is also moving in the same direction to that of your jet. The jet is deflected. Basically, jet is deflected through an angle of 150 degree. So phi, that is what we call as exit angle phi, is nothing but 180 minus 150 is equal to 30 degree. The relative velocity is reduced by 10%. Means what? If inlet relative velocity VR1 is equal to V minus U, is that so? Then that particular relative velocity at the exit will be like this. VR2 is equal to 0.9 of that of your VR1 because VR2 is equal to 0.9 that of VR1 because it is given in this numerical that the relative velocity is reduced by 10%. So 10% reduction is nothing but 90%. So 90 divided by 100 it will result into 0.9 as if VR1. So these are the given conditions related to this particular numerical. Now what we need to find out is that the force exerted on a wind. Okay, so this numerical, it has some specific significance related to that of your finding out the force. So first of all we will try to understand how much amount of force is being exerted. So first of all we will find out one by one all the values related to this analysis. So inlet velocity is what? At the inlet, what is the velocity of the jet? Obviously jet is striking a kind of plate which is moving with velocity 14 meter per second. So while striking this plate, the velocity will be like VR1. That is the relative velocity at the inlet. V minus U is equal to 60 minus 14. So this is the VR1 and that particular value we are getting as 46 meters per second. Now next is to find out basically VR2, that is relative velocity at the exit. So relative velocity at the exit from this analogy which is given in the problem is 0.9 or we can say 90% of VR1 and it is getting as 41.4 meter per second. So this is what we call as a VR2. Now the cos phi. Now from this diagram let us consider this outlet velocity triangle. After exiting this particular wind, the velocity or we can say jet is supposed to travel like this VR2. Okay, it should follow this particular direction by making an angle of phi, but because of forward inertia, forward momentum, this jet is supposed to change its direction like this beta. So this water jet is exiting, trying to exit from the moving wind. So at that time obviously it takes the same direction. It will get a kind of forward inertia in such a way that instead of following this path, that is what we call as a VR2 as a velocity, it is going to follow this V2 as a, or we can say this direction. So here we will have an absolute jet. This one is what we call as a relative jet velocity and this one is what we call as a absolute jet velocity at the exit. Now this V2 has two components, VW2 and VF2. Okay, so VW2 is nothing but the tangential velocity component, okay, and VF2 is nothing but axial velocity component, or we can say flow component. One more thing, at the inlet we don't have any type of, we can say flow component, okay. Absolute velocity is equal to tangential velocity, okay. So while striking it has a kind of velocity, that is what we call as a VR1. Now we will find out all these values related to the exit velocity, or we can say all the exit velocities. So how to find out all these things? First of all, we will find out the one of the velocity, that is what we call as a u, and based on that we can find out VW. Okay, so we can write with the help of trigonometry, basic trigonometry, cos phi is equal to, here is the phi angle, so cos phi is equal to basically this side, which is nothing but addition of u plus VW2 divided by this side, which is nothing but VR2. So from this we have phi, we have u, and we have VR2. VR2 we have found. So what you will get here, cos 30 is equal to u is nothing but 14 plus VW2 we don't know divided by VR2 41.4 meter per second. So from that VW2 will be, basically we are getting as a 21.8535 meter per second. So this is the value of VW2. Okay, now we have almost all the values related to the force. One more thing we need to find out is nothing but basically the flow component, because we have to find out basically we can say the mass flow rate, or it is necessary to find out basically power. So we will find out that thing also as an add-on. So sin phi is equal to VF2 upon VR2. So if we put all the values in this equation, we will get VF2 as 20.70 meter per second. Now for series of waves, we can write the equation of, we can say, force, and directly the power developed as m dot VW1 plus VW2 into u. So this is the formula for power developed, and it is given by basically rho a v1. Here we have cross sectional area VW1 plus VW2 into u. So rho is 1000 into area of the, or we can say cross sectional area of the jet, as if we have that particular jet is having a kind of discharge. So for that sake we have to find out. So here the area pi by 4 into d square, here in this case that thing which is not written is nothing but diameter is 2.5 centimeter. So based on that we have 0.025 bracket square meter square into the velocity v is nothing but 60 into VW1 is nothing but 60 plus VW2 is 21.8535 bracket complete into that when velocity as u. Okay. So from that we can find out that particular value is 33.750.984 watt. Now the efficiency, for the efficiency we must have to find out kinetic energy is equal to 1/2 into rho into AC into VQ. So we will have that particular value as 53,014.38 watt. So efficiency of jet is equal to basically this upon this, that is work done divided by kinetic energy into 100, and it is given by basically 33.33750.984 divided by 55 5014.38 into 100. So that particular value we are getting is 63.66% as if the efficiency of this jet. So from this we can understand that particular thing related to the we can say how to find out force exerted on a curved vane if it is moving with velocity u and having a kind of geometry like this. Okay. The next problem is the jet of water having velocity 35 meter per second impinges on a series of moving vanes with a velocity of 20 meter per second. The jet makes an angle of 30 degree to the direction of vane motion when entering and leaving at an angle of 120 degree. Find vane angle at the inlet and outlet, work done per unit weight of water, and last one is nothing but to find out efficiency. Now here a jet of water having velocity 35 meter per second. So here is a jet of water having velocity v1. This is the velocity, absolute velocity of the jet. Okay, so 35 meter per second. Impinges on series of vanes. So these are series of vanes moving with velocity 20 meter per second. So each vane is moving with the same velocity 20 meter per second. Now here we have a kind of thing that the jet makes an angle of 30 degree to the direction of vane when entering and leaves at an angle of 120 degree. So while entering, this jet makes an angle of 30 degree with the direction of vane, motion of the vane. So motion of the vane, let us consider as a positive x direction, and with this positive x direction it makes an angle of 30 degree while entering with this velocity 35 meter per second. While leaving, it makes an angle of what? 120 degree. So here is the case that if we assume that this is a kind of vane, so that because of, we can say, striking, because of forward momentum, this particular jet leaves this vane with this direction, which is making an angle of 120 degree with this positive x direction, that is the direction of vane motion. So here is the thing that we need to understand in this particular problem. So this angle will be 120 degree. So 120 degree, and this one angle is nothing but that angle is to be find out, that is beta angle. Okay, so beta angle will be like this. Basically if this one is 120 degree, this total angle is basically 180 degree. So 180 minus 120, it will become 60 degree. So if this angle is 60 degree, this one is also 60 degree. So here we can consider this particular angle as beta is equal to 60 degree. Okay, so now we will just try to find out what is given in the problem. So given is equal to, basically jet velocity v1 is 35 meter per second, u is 20 meter per second, then alpha is equal to 30 degree, beta just we have found out is 60 degree, and rest of the things that we need to find out. What we need to find out is nothing but basically vane angle. So we have to find out theta and phi. Then after we have to find out work done. Then after we have to find out efficiency of the jet. So these three things are to be found out. So we will see that thing one by one. First of all, what we need to understand is how to find out work done. To find out work done, we must have to find out force, and to find out efficiency, we must have to find out input energy. Before that, we have to find out angle theta and phi. So how to find out phi and theta angle? With the help of basic geometry, we can find out all these things. One more thing, here in this problem they had not given you any type of reduction in velocity VR1 to that of your VR2. So means what? VR1 is equal to VR2. So let us assume that thing as VR1 is equal to VR2 in such a way that here we have a frictionless vane. If it is so, then we can say that because of frictionless vane, VR1 and VR2 does not have any type of difference. From that, now we will just try to find out all the values. First of all, from this diagram we can find out V1. From the V1 we can find out VW1 as V1, basically here in this case VW1 is equal to V1 cos alpha and VF1 is equal to V1 sin alpha. So these two values are essential one in such a way that we can find out these two components of velocity. So VW1 is found to be 30.31 meter per second and VF1 is found to be 17.5 meter per second. So from this we have found out VW1 and VF1. Now U is what we call as the velocity of that particular jet, and that velocity is given here is 20 meter per second. So this particular thing related to that of your velocity U is already available with us. So from this diagram we can find out theta in such a way that tan theta is equal to opposite side is VF1 divided by adjacent side is nothing but this component. Let us assume that this one is x. So that x is nothing but VW1 minus U1. So we can directly write down that thing as VW1 minus U1. So we will get theta is equal to tan inverse of, now we will put those values in this equation. VF1 is 17.5, VW1 is 30.31 minus this U is 14. So what you will get is theta is equal to 60 degree. So this angle will become 60 degree if we solve these values. Okay. Now the next thing is to find out basically the VR1 value. So VR1 can be found out like this: sin theta is equal to VF1 upon VR1. So VR1 will be like rearranging that equation. We have theta value, we have VF1. So VR1 is equal to VF1 upon sin theta is equal to, after putting these values in this equation, we will have 20.21 meter per second as the value of basically VR1. Now VR1 is equal to VR2 as I told you. So VR1 is equal to VR2 is equal to 20.21 meter per second, as if we have a frictionless surface. So from this you can say that as if we have a series of wings which are moving in the same direction. So U1 and U2 are same. So U1 is equal to U2 is equal to, basically as it given wind velocity as 20 meter per second. Sorry, I have written here 20 meter per second. Okay, so from this now we can find out the exit angle. So at the exit of this particular, we can say velocity triangles, what we have to find out is tan beta is equal to VF2 upon adjacent side is nothing but VW2. So this VW2 is equal to, or rearranging that particular equation for this case as VW2 is equal to VF2 is equal to VW2 into tan beta. So this one is VF2. Now from this particular whole triangle, outlet triangle, we can write down a kind of trigonometric equation, or we can say applying Pythagoras theorem, we will have VR2 square is equal to U2 plus VW2 bracket square plus VF2 square. So VF2 is nothing but this value. So we can directly put all these values in this equation in such a way that VR2 is 20.21 meter square, U2 is 20 plus VW2 is to be find out bracket square plus VF2 is can be written in form of VW2 tan beta. So here we have tan beta square. So here we have quadratic equation and VW2 is a kind of variable. So we can solve this equation for this VW2. So VW2 is equal to, in that case, will be 0.2068 meter per second. After solving, you will get that particular value in calculator. Okay, so work done is equal to m dot VW1 into U1 plus VW2 into U2 divided by the kinetic energy is nothing but basically, or m dot g. So m dot g is nothing but we can say the kind of potential energy available on either side of this particular system. So m dot get cancelled out, and we will get a kind of equation, or we can say as if we have to find out this work done per unit weight of water. This is the weight of water, so we will get that particular thing as 62.22 Newton meter per Newton as work done per unit weight of water. Okay, so this is all about, we can say, a kind of thing that is available with us. Now the efficiency is nothing but, efficiency is given by, efficiency is equal to 2 VW1 plus VW2 into U divided by V1 square. So this can be written as, by putting all these values available, these and all the values are available, so we will get 99.64% as the efficiency of this jet series of vents.